Hi, my name is Leandro Facchinetti, and let's write some code together, shall we? What we have on the menu today is finally the tone generator. I have been promising this for many sessions now, and we are finally going to get into that. So let's jump right in and start by muting the master, because this time we are definitely generating noise, and we will generate loud noises to begin with. I'm going to create a new JS effect, and I'm going to call it... I'm actually going to give a bunch of names, because when you have this effect installed, I want you to be able to find it with multiple keywords. So I will call this an oscillator. But also, I will call this a tone generator, and I'll call this an LFO. Yes, I have big ambitions for this one. I think that the same effect can be an oscillator, which is a tone generator, and it can also be a low frequency oscillator. And I think I can do all of these in one effect, and we will have options to toggle between a regular oscillator and low frequency one. We'll get into that later, and we may not be able to build everything in just this one episode. We'll see. Anyway, okay, so this is the boilerplate code that we never use. And I also want some other effects here to monitor what I'm doing. So I want an oscilloscope, and we have built one previously. So this is the oscilloscope. I'll have it around. I will also want a tuner. So there is one that comes with Reaper. We may build one in the future, but for now, that's the one we are going to use. And first, to begin with, I guess I'll put this maybe here on the top, the tuner here, and then maybe this one over there. Okay, so the first thing I want to do is to get to something that oscillates as soon as possible. So let's start by creating a sample section of code, and we will start by just assigning sample 0 and sample 1 to a sine wave. And I need to pass a parameter here, and I want this parameter to increase over time. So I'll just have a counter here, and it starts with 0 because every variable in JS effects start with 0. So when I say +1, for every sample, the counter is going to increment, and then I can use the counter here, and we have something. This is a very loud noise, but we have something, and it is a weird shape, but it kind of looks like a sine wave. So this is already something that is oscillating, and it's oscillating at this frequency. So that's why we need here the tuner, because this is going to give us the shape of the wave, and this is going to show us the frequency of the wave, or at least what it thinks the frequency is. Anyway, so this is a simple way to make a sine wave. And if we take the counter and divide it by a big number, then I think that we'll have a shape that looks differently. We can zoom out. Okay, so this is looking better now. It's looking like a sine wave. I can pause this, and now it looks like a sine wave. So the problem before was that the frequency was so high that you didn't have enough samples to see this shape. But when I just decrease the counter, I'm not actually decreasing, I'm dividing it, but I'm making it a lot slower to progress. So another way of doing this is, instead of having +1, I could have like +0001. And then we can play again, and we should see a sine wave. Well, maybe this one is too slow. It is oscillating, but it's oscillating very slowly. Now we have a fair sine wave. And I have no idea why the tuner is no longer working. Well, I guess it's just not picking up any frequency. It's not able to pick up the frequency of this wave. I don't know. We'll see what happens when we actually have a frequency that we know and that we expect to see that frequency. So that's the minimum we have to do to make some oscillation work. It's very simple. It's a small piece of code. There are two things that I want to do with this first. One of which is to have control over the frequency. And then we are going to look at the thing here and we should see the right frequency. And the second thing is I want to have different shapes. So we'll have control over what shape the wave has. This is a simple sine wave, but I also want to have square waves, sawtooth, maybe some white noise, that sort of thing. So let's start with the frequency problem first, because I think it's interesting. And I think they are separate problems. We can, if we are smart about this, we can separate the problem of finding the right frequency and the problem of constructing different shapes. Let's start with the frequency. So I will have a slider. This will be slider 1, and this will be the frequency. To begin with, the frequency will be 440, which is the default tuning for almost all Western music. And we will be able to oscillate to pick frequencies in the hearing spectrum. So for now, this is not a low frequency oscillator. We are lying on the name because we are only picking frequencies that the human ear can hear. And I will change 1 hertz at a time. So this is the frequency in hertz. And now I want to do something with this frequency. More specifically, I want this counter to change in a way that respects the frequency. So a frequency of 440 hertz means that for every second, we will hear a cycle 440 times. And this cycle, for now, is a sine wave, but it will have different shapes later. So the way I think about separating the problems of frequency and dealing with the shape of the wave is I'm going to have a wave that oscillates on the right frequency, and this wave will go from 0 to 1, from 0 to 1. So we'll have an oscillator that doesn't go from -1 to 1, it goes from 0 to 1, because it's easier to work with numbers that are normalized like that. So we'll have a wave that oscillates on the right frequency, and it will go from 0 to 1 linearly. So it will look like a sawtooth. It will go from 0 to 1 linearly and then drop, and 0 to 1 linearly and then drop again. Okay, so the way we are going to do that is with an idea of cycles. And the cycle is independent of the shape of the wave that we end up building, like this sine wave. So I'll say that the cycle starts with 0, and I'll do that by putting this code here in the init block that only runs when the effect is initialized. And I want to increment this cycle. Remember, so the cycle variable will go from 0 to 1. So I will do some incrementation of cycle, like so. But I will also check if cycle is greater than 1, then I want to take this cycle and subtract 1. So now the cycle will go up to, let's say, 1.1, and in that case, it will cycle back. It is, the subtraction here is going to take 1. So if you get to a cycle that is 1.1, it will cycle back to 0.1. And this way, we are keeping this variable in the range between 0 and 1, as long as our increment is always between 0 and 1. Because if we had a cycle of like the number 2, then this would be, or maybe the number 3. Suppose that the cycle is the number 3. Then in that case, it doesn't work because it goes back to the number 2. But we are going to guarantee that these increments are always between 0 and 1. And so the cycle will always be between 0 and 1. So if I save this, then we start to have something that looks like the shape I was talking about. It goes from 0 to 1 and then drops back. So it's starting to look like a sawtooth. But it doesn't respect the frequency yet. It is just going up by this amount, and then it's cycling back. So if it's greater than 1, then you subtract 1, so you get it back here, down. So this -1 represents this drop. This is similar to the treatment of circular buffers that we had in many other episodes, from RMS to the oscilloscope, and I guess in other places as well. In the code review for the auto mixer, we talked about circular buffers as well. So you can think of the cycle here as something equivalent or similar to the the index, the pointer that you have in your circular buffer. And in a way, you can think of this sine function as, well, the sine is a function and you're just picking values as if the sine function was a circular buffer, and then your cycle variable is the pointer, the index into that buffer of sorts. Okay, so the cycle needs to change in a way that respects the frequency. So we have to think about the frequency as, for instance, the frequency here of 440 is 440 cycles. We would like the cycle to occur that many times per 1 second. And this is not really minus, it should be something like this. Or maybe the word per. So 440 cycles per 1 second. And we are not dealing here with seconds. This code doesn't run every second. It runs every sample. And we have, for instance, in my setup, we have a sample rate of 48,000 samples per 1 second. And what we are really interested here, of course, this number is variable. So the 440 really is the frequency variable that comes from here. And the 48,000 isn't really that fixed number. It really is the sample rate as given by Reaper. Somewhere in here, you will see a sample rate variable, and I don't know where it is, but it's there. It exists. It's probably down here. Yeah, the sample rate is 48,000. So that's our sample rate, and that's a variable that is given to us by the JS Effects environment. But what we are really interested here is not any one of these measurements. It is the number of cycles per sample, because that's the amount that we need to increment here instead of this hard-coded number. So I'll try to make this look nicer. Let's see if I can. Something like that. Okay, so what is this number? Well, in our case, first of all, we have these two numbers and we know that the result needs to be between 0 and 1. So a good intuition is to say, okay, just take the two and divide them, right? Because this number is smaller than this one, so just take the frequency and divide by the sample rate. And that is a great intuition because, in fact, it is a number between 0 and 1. In this case, in particular, it will be 440 divided by 48,000. So it will be this small value. And that's a good intuition to start with. And it's also the right answer. And that's because we are always working with 1 second here. And another way to think about this is that we want the thing in cycles per sample, so we can divide this line that has to do with cycles by this line that has to do with samples. So we're just taking, it's as if we were writing here a big division between the two. And that's what you end up with. So if instead of having this hard-coded number, we had frequency divided by the sample rate, then we can look at the effect window. So we'll bring it up here. And because I just created the slider, the frequency is 0, but of course I can change this. And I'll put this here. And I'll leave this here. Now this window is too small, so maybe I have to do this instead. Then I can go and pick the window here, there. Anyway, so now we have something that is oscillating 440 times per second. And I know that because, first, it has the right shape, okay? So it's going from 0 to 1 and from 0 to 1. So it's oscillating with the right shape. But also it has the right frequency, and I can tell that by the tuner that started to work again. So I guess it just couldn't pick up the frequencies before because they were so out of range that the retune thing couldn't pick it up. But now it can. So if I change this to like 1,000, then it changes to 1,000. Yes, there is a small error here, but it's good enough. And I can also look at this, and it has the right shape. And I guess I can maybe leave this playing and I can move this around. And this number moves around correspondingly. And if I go up, way up, then the retune thing doesn't work anymore. And I guess that has to do with the fact that, as we saw before, if we have something that oscillates so fast, then you don't even have the time to see a full cycle. You don't have enough samples to render the full cycle, and that throws off the tuner. But for small values like this, 440, then you can see the whole shape if you zoom out. You see the whole shape, and you can play around with this, and the tuner will go along correspondingly. Yes, with a small error, but good enough. And the bigger the value, the bigger the error as well. And it wraps around. So when you go from 6 to like 10, then it starts wrapping around and becomes a small value again. Okay, so that is the cycle. And now we will do different things with this variable to turn it into different shapes. So now we have dealt with the frequency. By defining the cycle variable this way, we have dealt with the frequency. Now we have to deal with the shape. And I forgot the sine thing here. So it's still doing the sine thing. Yeah, if I take it out, then it looks better. It was kind of looking strange, and I guess at first I was looking at it and I thought, well, maybe it's some kind of floating point arithmetic error. But no, it was the sine thing that was doing the wrong thing. So yeah, our shape here is pure. It is great. And even with that, the frequencies are still right. So we can change them to like 2800, and it's around the right place. And if I bring it down to 2000, it's almost there. And 440 is almost exact. And when I play, I see the shape, and I can play around with this, and I can see different shapes coming together, which I think is excellent. All right. So now let's do the actual thing to render a sine wave using this. So the thing about the sine function, and this is not something that is specific to JSFX, this is something that has to do with the sine function itself, the mathematical function, is that the cycle of the sine function is not from 0 to 1, it's from 0 to 2 pi, 2 times pi. So I have a number between 0 and 1, but I can multiply it by 2 times pi. And I don't think we have seen this before, but it's a variable constant, not a variable, a constant in JSFX. So you have this $sign pi. I guess you also have $sign e. And I don't know if you have other ones. Those are the only two I know. And I don't think they are documented anywhere. You just see this in some other effects and then you start using it. So at this point, our oscilloscope is looking really good. The shape of the wave is right. The frequency of the wave is right. I want to hear that. But to hear it, I need to bring the volume down, because for now it's going from -1 to 1, and that is as loud as it can be. That's too loud for us. So we will have here a slider, and this will be maybe slider 64, the last one. And this will be the gain in dB. It will start with something like -18. You will be able to go from -62 up to 6. Is that a smart move? Not really, because it will be absolutely clipping. You know what? I'm going to allow you to go to 0. And I'm going to give you steps of 0.1. 0.01. And that's your gain. Or maybe I'll call this output, because I think in other effects, this is called output. So I'll call this output in dB. And this is something that we have done in many other episodes. So if you are interested in learning how this formula that I'm about to write works, then you should check the other video in this channel in which I explain the simplest effect. It's just a conversion from dB to amplitude. And the formula is 10 to the power of the amplitude, the output in dB divided by 20. So you take the amplitude and you multiply it here. And now we'll bring up the sliders for our effect. We have an output dB. And when we bring it down, it is not doing anything because this code is only running when you when you start the effect. So I guess I'll change this to the slider section. And then I can bring the volume up and down. So with that, I can bring the volume down. I can put on my headphones and we will actually hear our tone generator. So I will unmute this and I can start to hear it. I'll bring it up slightly. And I'm going to change the frequencies. Yep, it sounds annoying and it sounds about right. That is a tone generator with a sine wave. Now let's look at different shapes. And let me make sure that I have the master muted. I do. So now we'll look at different shapes. This is the shape of a sine wave, but we can have like this, the shape of a square wave. So I'll take the sine wave out for now. And I'll leave this in a comment for now. And I will do a square wave. A square wave is if the cycle is between 0 and a half, then I'll set this up. And if the cycle is between a half and 1, then I'll bring this down because we have a number between 0 and 1. So all I have to do is I'll have like my output signal is equal to, I'll check, is the cycle less than a half? If so, my output signal is, oh, I guess I can do this in one line. So I can say, is my cycle less than half? If so, then I'll let the signal down, okay? Otherwise, it is up. And if I do it like this, then I have a lovely little, oh, it shouldn't be 0, it should be -1. I have a lovely little square wave here. And I can bring up the volume and we can see a beautiful square wave. So that is a sine wave. This is a square wave. For sawtooth, what we can do is just, first of all, our cycle function, it already looks like a sawtooth. It's just offset to the top and it's too short. So if I leave the amplitude at 0, then it's too short because it only takes half the spectrum. So what I want to do is take this number between 0 and 1, multiply it by 2. Now I have a number between 0 and 2, subtract 1, and put that in parentheses. And then I have a number between -1 and 1. And yeah, it is a sawtooth. It is going up and down that way. Let me pause this. So it's going up and down this way. So it starts down and goes up. And I'll call this, I'll only take this part. I'll call this sawtooth. And I'll say that this is down, up. And of course I have there is also the converse, the one that goes from top down. So to build that one, we start with a similar formula, but we have to invert everything. So what if we just multiply by -1? And let's see if that does the trick. I think it does. Yeah, so this one is just going from top down. So I'll take this whole formula. Oh, I guess I can refactor this to multiply the -1 over here. So maybe I can just do it here. Yeah, multiply by -2. If I save that and play here, oh, it doesn't work because of the -1 that happens after. So what I need to do instead is really multiply by -1 after the fact. So there is no good refactoring to do here, I don't think. This is a sawtooth, up, down. And are there more shapes that I want to do here? Maybe. Let's think about it. You know what? I think there are more shapes that I want to do, but for now, I'll stick with these ones and we will return to this in another episode. But there is a few more things that I want to do before I leave, and that is to actually combine all these into one shape. So we'll have a bunch of sliders to set the gain on all these different shapes. And then we'll be able to mix and have shapes that combine some of these. So we could have a wave that looks like a sine combined with a square. We'll have now a bunch of sliders. I'll have maybe slider 3. I want to skip slider 2 to have a gap in the interface. So you can see, for instance, here in our current interface, there is a gap in between, and that's what I want. So we'll have the sine in dB, not in dB really. It will be just the mix, sine mix. And it will start with 1 because I want this one to be enabled by default. It will go from 0 to 1 and it will go in steps of 0.1. And I think that these steps of 0.01 may be too much. Let me see. No, it's actually reasonable. Yeah, it's okay. So I'll give you maybe 0.01 here as well. And this is just a mix, so just say the name of the wave. And now we'll have some more, because we have 4, right? We have 4 kinds of wave. So this is slider 4, 5, and 6. This is the square, the sawtooth, down, up, and the sawtooth, up, down. And all these other ones I want to be disabled by default. So when you open the plugin for the first time, it is a sine wave. And now this is a square. This is a sawtooth going from down, up, and a sawtooth, up, down. Also, I would like to have the width of the square wave change. I guess I need to return to that in a moment. No, I will do it here. I will do it now. So let's figure this out. So I have here this formula, and I need to take out the -1 as well. So that's the formula to have a square wave. If I change this number, I control the width of the wave because it's going right. The cycle is going from 0 to 1. If I divide it in half, then I have a pure square wave. But this makes it more rectangular like that. So I can have maybe the slider 5 could be the square width, and it will start in half. I'll allow you to go from 0 to 1 in steps of 0, 1 as well. And this is the width. So probably I need these sliders to skip so that they are grouped together fine. So I'll do it like 8 and 9, like that. Let's look at the interface, and I have the frequency that looks about right. And then I'll reset everything to factory defaults. Yep. So now, the interface doesn't look right. There's something wrong here. Did I forget to save something? Oh, I forgot to change this. This should be an 8 and this should be a 9. So I made a mistake there. Now this is better. So I can play with this and it should change the width of the wave. So I can come here to this square width and change it there. Now when I play with the width, it changes over there. And I can make the width 0, which is nonsensical because then it's just a line. But nevertheless, and also when it's 1, it's just a line. And when it's like this, then it has different shapes. And that's what I want. So now this is separated from frequency to sine to square, the width of the square, sawtooth, up, down. And I guess I should have another space here because I have spaces over the different shapes everywhere. So I'll say that this is the slider 10, and then there is a space here. And then there is the final output in dB. And these numbers between 0 and 1 are multipliers. They don't have a magnitude. They don't have a unit of measurement. That's what they don't have. They don't have a unit of measurement because they are multipliers. So now we are ready. We have everything we need to do the mix of all the different shapes. Oh, and before I do that, I hate having this line here because this effect, it could be multi-channel. It's so easy to do that, so I'll do it. Channel equals -1. We have done this many times before. To loop over every channel, we need to know the number of channels, and we'll say channel plus equals to 1 is the first thing that this block of code does. And then we can take this whole thing that we are doing and apply it to the sample at a current channel. Now this is multi-channel, no need to repeat code. And this allows you to have tone generators that generate 5 different channels. Isn't that great? 5 not 5. That's an odd number. You can have 6 channels if you want. You can have 64 channels if you want of your tone generator. Anyway, so that's how you cycle over the channels. So now we want to combine all these different formulas. And I'm going to do it like this. I'll put some spaces there. So that's the formula for the sine wave. And I'll multiply this by the sine mix. And to combine the different waves, so this is going to set the amount of this wave that I want. But I can add the different waves together, and they are going to combine together. So this is how you combine the different waves. And a square wave looks like this. Oh, I forgot to change the formula over there. So I guess this is out of date. This should be the square width. And then I'm going to combine with the sawtooth going up. I definitely need some parentheses in there. And I will multiply this. Oh, I forgot to do it here. This is the square mix. And then this is the sawtooth down up mix. And next is the sawtooth up down. Put everything here in parentheses. Guess I don't need the parentheses, so I won't put them. And multiply by that and then add. Okay, so all of these together, all these 4 added up together give you the output signal. I'm going to do it like this. So all of these combined give you the output signal that I then multiply by the amplitude. So you have one knob to change the amplitude of everything. So now I have a frequency, sine wave, no square wave, no sawtooth, and at this, I'll make it slightly louder. So now I can take some of the square wave and put it in. And now I have some a shape that is part square and part sine. You can take out some of the sine and you can see it morph like that. And I think it looks super cool. I bet that it sounds cool too, and we'll see that in a moment. And you can combine a sawtooth, so you can bring in all these different shapes, and I bet that this sounds great. Oh, what happens if you combine? If I take out all of them, then you hear pure silence. But what happens if you combine a sawtooth going up and down and another one going down and up? They cancel out because they interfere destructively. Interesting, super cool. But there is a problem, I think. If I have this and I bring in some of the square wave, oh, I thought it was going to go and clip, but it doesn't. What if I bring in some of the sawtooth? It doesn't clip either. I was worried that this was going to clip. Yeah, it can clip. See, when I have a sine wave and some sawtooth, it clips. Also, if I have a square wave and... Oh, look at that shape. It looks awesome. Yeah, it's clipping now. So I can bring down the volume here and you will be able to see it clipping because it will go over and then it's clipping. So we don't want that to happen. My idea here is that you will be able to morph between the shapes, but you never have to tweak the output knob. The output should be consistent. It should always be the same multiplier. And yes, in some cases you have some destructive interference. So I don't know exactly how that will pan out. But my idea here is that we could normalize the mixes because we have the mix from 0 to 1 in all 4 shapes, and we will have more shapes in the near future, I think. So we could have a lot of them, a lot of these mix variables, and they could add up to more than 1, right? They can add up to 5 or more, or 15, depending on how many shapes we have. And this is obsolete now. We have pasted the formulas down here. But what I thought I could do is just normalize the mixes. So sum of the mixes is this plus that plus that plus that. And then we take each one of these and divide by this sum. Let's see what effect this has. So now we have only the sine wave on the screen. And when I bring up the square wave, it morphs, it changes. It has some effects on the gain, but it's guaranteed to never clip. So let's do the experiment again of having a square wave and a sawtooth. So yeah, it's changing in shape, but it's never increasing in volume. It may decrease in volume if the shapes have destructive interference, but they are guaranteed to never increase in volume. Another way of seeing this, so one way of seeing this is in this graph, it never goes up, but you can also see it here, it never goes up. I guess I can make this -6 and we'll be able to see this very clearly. So if I have, and another effect is that when I have only one of the shapes, so they are all 0 except for the square wave. So if I have this, it doesn't matter where the slider is here because I'm normalizing it, so I have only the square wave, and you can control the volume independently, which is, I think, is a nice feature. So if I have it here as -6, then I can bring in anything, and if they don't have destructive interference, then the volume stays constant. And if they have some destructive interference, then the volume goes down. But I'm guaranteed to never blow your speakers if you just change the shape of the wave. You can always make it fainter, but it will never explode anything. So with that protection in place, now I would like to bring this volume way down and put all these sliders on their default values, because we are going to hear this and we are going to hear this. I wonder if I should have kept that comment. No, the comment was stale. I wonder if I should keep this comment. I guess I don't need it. If people are interested in knowing where this came from, then they can just watch this video. So I'll keep just the code here. And I'm super excited about hearing this. So I will unmute. I can hear the sine wave. It's super quiet, but you can hear it. I'll bring it down slightly. I bring it up. And I will zoom in to this shape using the oscillator because I don't want to make it louder. I just want to see it better. So now I can change the frequency. Bassy. And I can change the shapes. And it's interesting that when I was changing the shape, the volume was going down. You can see the volume going down. And it comes back up. I have no idea what's going on there. But what's interesting is that it sounded the same loudness because the shape of the wave is different. So we hear it as a harsher sound, and at least to my ear, it sounded about the same volume. Okay, so that was fun. That is a very simple oscillator or tone generator or LFO. It's not really an LFO yet. You could think, oh, this is not an LFO. It's not oscillating the right way. It's not oscillating slowly enough. Well, look at this. So I have everything in place. I'll bring the volume up, and I'm not blowing anyone's ears because the master is muted. But I can zoom into the shape. It has this weird shape, and I am going to just make it normal again. And I can come in here and type any value like 0.1, and now it's oscillating super slowly. So Reaper respects whatever value you put here, even if that value is not in the range that the effect set. So now this is a low frequency oscillator. I can zoom out and you can see the shape of the oscillator. You can also see it here. So yeah, in fact, this is a low frequency oscillator. It may not look like one, but it is. And this is going to behave weirdly, right? I combined two different shapes here. So yeah, this is a low frequency oscillator. It is a very weird one to use. So in the next episode, we are going to revisit the tone generator to just add some user interface so that you can control the frequency for the low frequency oscillator. We are going to add a new mode. We're also going to put a graphic here that's similar to this one, but it's going to show you the shape. So when we have those weird shapes like this one, I want to draw this shape over here in the effect just so you can play with this oscillator without having to have an oscilloscope also open and zoomed into the right way, and you can change the frequency and that visualization will stay the same. Well, this one changes if I bring it here. Now you can no longer see the shape of the wave, but you would still be able to see the shape of the wave here. So I have a bunch more ideas of where I can take this tone generator, but I'll leave this for now. We did a bunch of shapes. We looked at how to work with the frequencies, and I guess that's good enough for this episode. I hope you liked it. I hope you subscribe to the channel to see the new effects that I am making, and also to see all the other things I make with Reaper, all sorts of rescripts and automation to truncate silence and auto mixer, video editing, a lot more. I'm also talking about some other programming topics as well. I promised that for a while, and I'm finally doing it. I talked about Racket a bunch in 3 different videos last week, and I'm going to do other things related to Node.js and web development and all sorts of fun stuff. So make sure you subscribe. Thanks for watching this, and I see you on the next one. Bye.